Hello everyone. So in this video we're gonna look at relative displacement and the ways that we can differentiate between other entities of when it comes to relativity. So now in this series we're gonna study about relative motions. So when there's a motion, you know that different entities comes into play. First entity would be displacement, second velocity, and third would be acceleration. So uh, when we talk about relative motion, we're gonna have to redefine these things: relative displacement, relative velocity, and relative acceleration. So we're gonna have to come up with different notations. Now, when we're dealing with these relative entities, we're going to use vectors, vectorial pictures, and we will use graphical methods to get answers for the problems. So, since we are dealing with vectors, there should be a way to differentiate between these entities. That means, how do you how can you differentiate between acceleration and displacement? So we can have to come up with new notation. So I'm going to introduce you a new notation on displacement, velocities, and accelerations in this video, right? So we're going to look at this now. This representation, suppose there are 2 points in space. So we can start with displacement, relative displacement, because it is easier to visualize. In space we have 2 points, point A and point B, right? So suppose you are standing at point A and there's a person at point B, and you want to tell someone that this person B is standing right over there, right? So we can represent the location of B with respect to A. Location of B with respect to A using a vector. So how do you define it? You have learned this. The symbol that you can use is, you can use these 2 letters. The first letter will tell you from where it starts, and second letter will tell you where it ends, vector. So you use an arrow on top. So this says a vector starts from A to B. So this is also equal to BA in this way. Vector starts from A to B, right? Now what about this vector? This vector tells us that it starts from B and ends at A. So we can write it as AB starts from B, ends at A. Or we can write it as BA. So both representations are correct. So these are vectors, vector entities. Now if you want to represent the displacement, this is actually the displacement between these 2 points, because this is the smallest distance that you can come up with. So this is a vector quantity. A vector quantity has a magnitude and the direction. So the magnitude of this would be, let's say, simple D, right? Okay. Now let's talk about the displacement. Now if you want to talk about the displacement, you know the displacement is the shortest distance between 2 points. You can have to have at least 2 points. You can have to have 2 points actually to represent a displacement. Otherwise it is meaningless to talk about displacement. So it is always relative to a point. Suppose you are standing at A and you want to describe the displacement of B with respect to you. How do you perceive the displacement of B, right? So since we are dealing with vector quantities here, we're going to use different representation here. So the displacement is represented by S, displacement S. And if you want to talk about the displacement of B with respect to A, we can write it like this: displacement of B, comma, with respect to A, right? So S stands for the displacement vector. So you can represent it like this, displacement vector. If you like, you can omit this one because in certain books they don't have this arrow on top. The first subscript before the comma, the first subscript tells us whose displacement this is, right? And second subscript tells us with respect to what. Okay, what about the displacement of A with respect to B? Displacement of A with respect to B can be represented as, okay, write it with B, displacement vector. To represent this is the vector corresponding to displacement of A with respect to B. Displacement of A with respect to B. And notice here they are both vector quantities. They are both vectors. So they have vectorial properties. Now, you know that the displacement of B with respect to A and displacement of A with respect to B, they are both equal in magnitude, right? But with respect to their directions, they are opposite to each other. They are only opposite to each other with respect to their direction. So these two are vectors equal in magnitude but different in direction. So you know that the relationship would be this vector is equal to the negative of this vector, right? Suppose, for example, if we have a vector A like this and a vector B like this, right? A is in this direction, B is in this direction. If magnitude of A is equal to magnitude of B, then we can say that vector A is equal to minus vector B, right? The minus sign represents that they are of opposite directions. That is the only significance there, right? So we made a now make sure you remember this, that displacement of B with respect to A is equal to negative of displacement of A with respect to B. So you have to remember this relationship. This is very important, right? So likewise, we can talk about velocities. And here, when we talk about velocities, we look at instantaneous velocities. Now suppose there's a particle P at A and there's a particle Q at B. They both have certain velocities. We don't know. So in this depiction, it shows that they're both moving towards each other. Now we can represent the velocity, relative velocity, because when you're talking about instantaneous velocities, you know that they are defined as the velocity at that particular point. So it is also again a relative entity. So just like with the displacement, we define the relative velocity of particle P with respect to A in this notation. This says that velocity of particle P with respect to A. So this reference point can be anywhere on this line or in any space there. Right, so like in this case, this is equal to negative velocity of A with respect to P. Velocity of A with respect to P. So if I were to give you an intuition on this, suppose that you are in a vehicle, right, and you are moving in this direction, and there's a person here standing at this fixed point. Now, for a person inside this vehicle, he would notice that this person standing at A is coming towards him. But for this person, he would observe that this car or the person inside is coming towards him, right? So directions are different, right? So that is the intuition behind this. We can discuss it more during the discussion session. So please remember this as well. Likewise, we can talk about relative accelerations, that is also with respect to a fixed point, and we can easily extend this to relative velocities between two moving objects. We will look into that in future videos, but for now we're just looking at the definitions. So acceleration, to represent acceleration we use A, simple A. Acceleration of P with respect to A is equal to minus acceleration of A with respect to P. So these are the three definitions that you have to remember. If you know these things, it will be easier for you to follow. Right, so I'll see you guys in the next video. Thank you for watching.